I'm talking about container management with Kubernetes and Gitlab. So this is a customer success story. We've been delivering this project in Germany for 2 years now, and we will dive into a bit how we did it. So this is the agenda. I'll do a first quick project introduction. So actually, what is it, what the client is doing, how are we helping him delivering what he needs to be doing. We're diving into the platform overview. So which platform did we choose? So how do we do the continuous delivery? How do we deliver the software? And then look a bit what's ahead for the client and for us as a platform, like we're the platform provider. And yes, that's it. So let's start. Who am I? I'm a technical architect in Accenture. I've been with Accenture for a couple of years. I'm working in the container platforms area and mostly focusing around Kubernetes. So everything Kubernetes is where my heart is. And yes, I'm from Berlin, so the Europe region is my region, but I made my way to Scandinavia. So let's have a couple of assumptions. So I'm pretty sure everyone has heard of containers, and everyone has at least heard of Kubernetes. So who hasn't heard of Kubernetes? I take that as no one. But I was told yesterday the Finnish audience is quite passive, so that might be a bit difficult, but we'll dive in there. So if you have any questions during my talk, please just ask. Yes, and maybe you're interested in implementations of emerging technologies in enterprises, because still containers are quite new, and container platforms are even newer than containers. And, well, maybe you're interested in German Rail, because that's what the client is. So, yes, I was talking about German Rail. So, actually, the client is German Rail, and German Rail consists of several divisions, and this one is specifically about station and service. So, what does station and service do? They are maintaining all the stations in Germany, which are about 5,000. And they're well, doing lots of real estate, but also managing the escalators, the elevators, and all the station itself, basically. The ad says, well, it roughly translates to, that's an ad, actually. It's a German ad. It says, Die Bahn kommt. It means the train is approaching. And this leads us to the question, when does it approach? So when is it coming? Mostly it's on time. It's not always, but mostly it is. And how does this information reach you? And this is where we start. So passenger information is our project, actually. So we are delivering this information to you as the passengers. And this is one way that this information reaches you, so via visual stuff. There's also audio and a couple of others. And this may look quite easy. So you would say, sure, that's just well, a simple screen. How complex can it be? And I can assure you it's quite complex. There are about 35 to 40 microservices involved to deliver this kind of information to you. So most of them are rendering engines for the different output devices and scheduling information. So because I don't want to see everything at once, I want it only when I need it. And yes, all these microservices in the back end, this is actually something we will talk about a bit. And we're doing this in complete Germany. So there are, I mentioned about 5,000 stations in Germany, and these 5,000 stations, they are processing 30 million passengers each day for public transportation in Germany. So that's quite a lot, I would say. But what exactly are we doing with Kubernetes now? So I mentioned it. What emerging stuff can we possibly do with Kubernetes? Well, we are managing legacy hardware and software. What else? So you have to excuse this slide. I was giving the same talk in KubeCon last week in Berlin. So it still says, hey, hello KubeCon. I should change that to Hello TechArch Day in Finland. And yes, so the history of the platform is a bit, or of these displays is a bit, well, special to German Rail. There are lots of different manufacturers involved to make these displays and to deliver those displays in the past. And each of them was not only building the hardware, they were also building the software which displays those informations. So there was a huge effort going on in maintaining the APIs. So German Rail was delivering the information up to the display, and then the display would take over. And since there were many different vendors involved, it was a real challenge, because hardware vendors are maybe not always good at software. So managing all those 5,000 stations, and as you can imagine, each station has a couple of tracks, and each track has a couple of those displays. So we have roughly around 40,000 maybe displays, and this has grown into a challenge. So these things are being replaced now. You're seeing the old display. This is, well, we have to power those legacy hardware for quite some time, I think about 10 years. But there will be new displays which are, well, as you would have imagined, TFT displays, very small, with a complete new rendering engine. Unfortunately, I don't have an image, but if you come to Germany, you will start noticing them at the stations. So let's dive into the technical stuff. I mentioned we were starting 2 years ago, and this is the container landscape. It's I adapted it a bit, so this wasn't the container landscape when we started, but it is a bit now. And I have to say, this is non-exhaustive, so please don't take this that there's everything in there. We have on the left there's a couple of layers. So we have the physical infrastructure, the virtual infrastructure, and then the containers take off. So this was the market area when we looked at it, and what did we end up for German Rail? Well, basically, we focused on Kubernetes. So Kubernetes was our place to go for the platform. And the story on the upper layers was still a bit blurry. So how do we actually deliver software on top of Kubernetes? How do we do release management? How is the CI/CD involved for the lower levels? So for the virtual infrastructure with AWS or any other cloud provider, the story is mostly there already. So we can look at experience others have. We can look at our experience we have with this kind of product delivery or project delivery. But for containers, this is quite a new area. This has some challenges for also for the infrastructure provider, because containers are there in a heartbeat, and physical infrastructure or virtual infrastructure on a cloud provider, it takes a couple of minutes to be there. So this is something not every API can cope with. For example, if I want to attach or detach and attach physical or network storage, this can, on AWS, this can take a while. So up to 10 minutes maybe, or up to 5 minutes. And with your containers, you're just, well, my containers is in 10 seconds, it's on a different machine. So this is something which we needed to deal with, actually. But let's well, as you can see on the bottom, there's AWS, and this is the platform where we're running on now. So AWS is the virtual, the public cloud provider. So the question might be, why didn't you use the AWS primitives? So there's ECS, there's EZ2, bare EZ2. There's lots of AWS products you might use. Why do you choose to, well, build the platform yourself? And that's a very valid question, actually, because there's some work involved in building and maintaining your own platform. So why did we do it? Well, we weren't always on AWS. When we started 2 years ago, we we were on bare metal. I say bare metal because we started actually with three little well, more or less gaming PCs. They had 8 GB of RAM and well, one even 16 GB of RAM, which served as the master. And we were prototyping, we were demoing, we were constantly we were evaluating the container area, and we started with our own network and our own hardware. Because well, the reason was the infrastructure provider, the IT provider for German Rail. They were in negotiations with, well, they wanted to move off their own data centers onto something more modern, with a public cloud provider or maintaining their own cloud in a data center. And the reference architecture for the old stuff, it was well, pretty old, and nobody wanted to build an old system in 2015. So we decided, well, we are doing something which is completely abstracted from the underlying hardware. We want to abstract the compute resources, the compute power, and we were focusing on delivering software on top of it. So I don't sorry, I don't care if this is running on an Intel or a Dell or whatever hardware there is. I care about, from a software perspective, I care about memory, CPU, and disk, and maybe network. But that's it. I don't care how it is implemented. How do you get me this kind of things? I don't care. And so because of this uncertainty, we started, well, going with our own approach of bare metal. We ran on this for the better part of the year, and it was really good. But at some point, we decided we want to be more serious. So we can't deliver this project on some gaming PCs. So we bought some Dell servers and built our own private cloud, which is a bit of exaggeration. So we had this Xen source running on the Dell servers, and we are managing our own private cloud, which worked and which was pretty good. But last year we finally were allowed to move to AWS, and well, now we have the public cloud. We can actually talk to an API and say, well, give me 100 GB of storage, or give me a load balancer, give me a DNS entry. All this is done via APIs. So I can just call an API and it's there. So that's pretty cool. And actually, I don't do that. I don't call an API. It's the platform which calls the API. Kubernetes will talk to AWS. I don't have to deal with it. When there's an application developer, he wants to focus on his application, so he doesn't want to deal with the infrastructure. Well, I would say, as an application developer, everybody knows that. As an application developer, I want to. And I want to say my application has 512 megabytes of RAM. It needs it. It needs one CPU. It has, in this environment, it has this DNS name. And it has a load balancer, and maybe it needs 10 GB of storage. And I describe this in a manifest, and I'll push it to the platform, and the platform should take care of it. I don't want to deal with application description in one language and then with infrastructure description in a different language, which is mostly Chef, Puppet, Ansible, Salt. I guess you've heard of them as well. And this was actually one thing when we started the project. Nobody of us wanted to do the application description in Chef or in Ansible, because that's just a bottleneck for the IT department, right? Every time an application developer wants to deploy something, they come to you and say, "Here, can you create this DNS entry, or can you provision me storage, or well, go to this environment and make something there." We didn't want to do that. That should happen in the application description and be solely there. And maybe another point here to mention is we didn't change the application description, application deployment process, or any of those during our infrastructure move from the left to the right. So we are still delivering and deploying applications the same way as we did on bare metal on the left. obviously now the infrastructure provider does a lot more nowadays. So like I said, there are APIs for giving me a DNS entry, and we didn't have that when we were on bare metal. So to go forward a bit, how do we manage applications? How do we deal with the version complexity? Because I mentioned prior to that, we have about 35 to 40 microservices, and they're just one environment. So from end to end, when we get the input information and delivering the output information, mostly, well, the complete stack is 35 services. And that's a lot. If you're doing continuous integration and continuous delivery, all those have their own version history. So you're deploying multiple times of a day, and you're moving from one environment to to another to another environment to the next one. So actually, we have, I think, mostly also around 10 to 15 environments, and every application in this environment, every single one has a lot of, well, version history, and all those needs to be fit together. I want to know exactly which kind of code is running in which environment. So when I see an issue in some environment, in a testing environment, I will go there, I will look at the container, and I want to, well, go back to the exact source code this was built from. And this is kind of in microservices, it's not an easy problem to solve, because you can't just deploy a million of microservices in every single combination. That's a huge challenge and a huge complexity. And sure, we want to overcome traditional silos, so nobody wants to like throw something over the fence and somebody else should deal with it. We didn't want to do that, especially from a platform provider perspective. So there should be a working with another, not a work against each other. So for Kubernetes, the answer is pretty clear. Let's kubectl. Who has used kubectl? Okay, cool. Basically, I'll just describe what it is. It's a command line tool for managing the platform. So as an application developer, I want to start my application, I want to stop my application, I want to see the environment of the application where it is running in, I want to debug it. I want to give it more CPU, less CPU. I want to I want to interact with it. So kubectl is kind of a process manager for the platform. The developer can run kubectl. He can start his applications. He can stop them. He can scale it. He can remove it. He can reroute it through his personal or his company laptop. So, for example, I have a stack with 20 services, and this one particular service, I want to for like true real debugging, I want to run it locally. I want to look at the stuff, and I'll just configure the other services to talk to my local service. So I'll do that with kubectl. I'll edit the other deployments, and Kubernetes will take care of applying the state to the application, and that's it's pretty easy to work with. And so this is the command line client. There are also web interfaces available, but if you're more technical and you get used to it, it's pretty fast. And actually, this is the only access to the platform. So I mentioned we're running on AWS, but none of our developers has AWS access because it's not necessary. We don't need to manage AWS credentials and platforms, IAM. And we don't need to do policies in AWS. So what are people supposed to do? There are only a very few people with having access to AWS, and all the rest has access to the runtime platform via kubectl or via a web interface. So I talked a lot about managing containers, but so how do we push code? And So this is the CI/CD marketplace. I'm pretty sure well some of the icons are familiar to you. Probably everybody knows the one on the left. This is Jenkins. Everybody has heard of Jenkins and has used it at some point in life, probably. So when we started, we weren't sure where we would end up with. So maybe we're doing a monolith, or we're using lots of those microservices. And we evaluated some projects during our lifetime, and in the end, we settled on Gitlab and GitLab CI as the continuous integration and eventually continuous delivery. But it hasn't been this case always. So there were a couple of challenges with GitLab, because when we started, it was just a tool focusing around CI. So it just builds the stuff, but it wasn't aware of the platform. It was kind of pushing these stuff too. So throughout our lifetime of the project, it evolved into a pretty major CI/CD tool. So we can actually create pipelines now. We can have a lot of different rules on where to deploy stuff and what to do, how to route stuff, depending on failure of the outcome of the previous job. And so this is something very important, because that's actually the heart of the software delivery. So this is how our CI looks like, very abstracted. And the main thing it allowed us for leveraging the benefits of the platform. When we started, it was like, okay, we can use a Docker container as the build image. So nobody has to come to us saying, I want to have Java 6 on the builder to create the package for Java, or I want to have 2 different Ruby versions on the builder, because this part of my application needs Ruby 1.8 and this needs Ruby 2. This is kind of a challenge, and we were pretty happy. So everybody can, every application developer or tester can maintain their own builder. They just push a different Docker file, and it will create a Docker image, and they can use it as part of the CI/CD process. So I'm free to do other stuff. Yay for that. So that was 2 years ago, but now we can actually auto-scale the CI. So the next problem is, if people are using the CI heavily, they tend to, especially as the end of the sprint, there are lots of CI things going on. So we are having 2-week sprints, and the sprint review is on Wednesday, and every Tuesday, this is like it's a really tough day for the CI, because there are lots and lots of builds. And so we needed a way to auto-scale the CI, because a static capacity for the CI was a bit old-fashioned. So we are running the CI the same way we run everything else as part of our platform on Kubernetes. So we are starting with spawning a new Docker container. We're getting the code out of GitLab, and we're running whatever stage it is defined in the GitLab CI file for this kind of application. And this is this is nice. We're running on the same platform, but we still have the same overall capacity we need to manage. So we have every instance in our AWS. When I open AWS Management Console and I look at the EC2 instances, every instance looks completely the same. So there are, not totally, but there are 3 master components for the Kubernetes control plane. But the rest of the instances, they're just like one-to-one. And we're running this as part of on those instances. But the real thing, and we are slowly moving there, would be to have a different auto-scaling group in an AWS, solely just only for the CI. So we would actually scale it when there's a job in the queue, or multiple jobs. We would scale up. There would be an instance provisioned. It will do the job. It will wait a couple of minutes, like maybe 10, execute different jobs, and it can scale to 10, 20, whatever instances. But it will be part of the same Kubernetes cluster, so we will be having a heterogeneous cluster. One part of the cluster is just for applications, runtime, and the second part of the cluster is for the CI. So actually, I don't have to provision this overcapacity for the CI on top of my more or less static application instances, because the environments, they don't change a lot. Sure, I provision a new environment, I remove an old one, but more or less it's the same. There's not such a dynamic thing like the CI, because on the weekend nobody should use the CI, right? I can just scale it down, I can save those resources. So I mentioned lots of apps. How do we manage all those environments on the Kubernetes platform? And on Kubernetes, there's a thing called Namespaces, which is a bit, if you're familiar with Docker and the container thing, like namespaces in the Linux kernel. So you have a soft isolation, basically. And we're using namespaces as part of Kubernetes as isolated environments. So we have all, well, basically everything is running on this platform. Our CI, our reverse proxy, our chat ops, our registry, DNS, well, basically everything, and our environments for the applications. And we're managing those. We have a default in every Docker file. It's, for example, if I have a service which needs a database, a Postgres, there's just a single name Postgres in there. And depending on the environment, it will just use Postgres, and Kubernetes will route Postgres to actually the Postgres service. So I don't have to deal with different environments and different names in these environments. I'll just, well, spin up a default, and I have a small file which configures the environment. So for example, from externally, I want to access this environment. I'll for sure I have to use a different URL to access this environment. So this is configured in a separate file, but this is, well, all there is to the differences between environments. This is just a couple of files in a YAML. And this helps us a lot to manage those environment complexity, because I don't want to deal all the day with describing environments and trying to make them work in a different in a different namespace. So how do we manage deployments? This is maybe a bit technical, but I was told this is a technical audience, so I hope it's good. If you have heard of Kubernetes, you may have heard of Helm. Helm is a application management tool, like think RPM for clusters. So I can install an application, I can remove it, I can upgrade it, all those kind of things. But it's not for a single instance. It's just for my cluster as a whole. It's in the same way. Lots of paradigms for a single node apply to a cluster as well, because you have abstracted your resources, right? So it's just a huge. Whenever the application is deployed, it sees a lot of resources. I have 150 gigabytes of RAM and 20 CPUs. They are just not on a single computer, single instance. They're distributed. And Helm is a tool which installs the application. So it's not just deploying a Docker container image, because the image is just one part of the story, right? So I mentioned I want to also describe the CPU, the memory, the URL, all those things basically, the lifetime, the environment. And I do this in the Helm chart. So this kind of lets me abstract and focus on only the part I want to surface to the developer. So I don't want the developer know all the internals of Kubernetes, so all those different YAML files, all those objects in Kubernetes. This is not something I expect everybody to learn, because that everybody is like into those kind of things. And with a bit help of a templating, I can abstract those things. And Helm makes this stuff works. Basically, Helm will apply some templating on some variables, split it out to Kubernetes objects, talk to the API server, and deploy. Kubernetes API server will deploy the stuff as Docker containers if you're using Docker on top of whatever infrastructure you run on. So this looks all fine, right? Yep, but there are challenges. And for us, the challenges were bootstrapping of Kubernetes. So I don't know, for those of you who have worked with Kubernetes, have you brought up your own Kubernetes cluster? So I guess you know what I'm talking about with bootstrapping of Kubernetes. It's not easy, but it's slowly getting there. But 2 years ago, it wasn't easy at all. So there were some scripts which would provision you a cluster, but well, that's a lot of complexity is hidden in a bash script. And as an enterprise, I surely don't want that. I want to understand each and every single option of those, what this thing does. So we were bringing up Kubernetes clusters manually, and that's a hard thing to do, especially if you're doing upgrades. So how do you upgrade your cluster? Kubernetes is evolving at a very fast pace, and lots of features are added every single day actually. And the release cycle is 3 months. So every 3 months you can actually upgrade, or you more or less you have to upgrade, because there are so many interesting and nice features coming your way, and you want to make use of them because they make your life easier. And this is a second point. In-place cluster upgrades are even now they are kind of hard with Kubernetes. So there's also limited debugging in containers, because you make your final image for the application, you make it very small, and you don't have any debugging to it. Sometimes there's not even curl in there or a bash, so you only have a shell, an ash if you're running Alpine. There are some legacy cluster apps, for example, RabbitMQ or Cassandra, or some sort of applications which are distributed, which need a leader, but they're built on the premise of there's a fixed IP address. I have a fixed identity. So you don't have that in container land. If your container goes away, it will come up with a new name, with a new IP address. And you have to deal with that somehow, so you have to work around a bit. And in Kubernetes, there's a thing called stateful sets, which gives a container an identity. So this is something you can leverage, but it's not working out of the box. And yeah, maybe the last one is, I mentioned there are lots of cool features in Kubernetes. So beware of alpha features. They work often as desired, but once they move to beta, there might be some API changes. You have to deal with that. So I have to hurry up a bit. There's the future for Kubernetes, which we want to some features we want to leverage is an app store. So we now have Helm as an abstracted installation tool, so everybody can use Helm. That's pretty easy. I just Helm repo add some repo. I'll do Helm up. It will get all those details about the applications in the repository, and I just Helm install whatever application. So that's pretty easy, but it's CLI only. An app store would allow me to make this available to the whole company. They can just browse a website and say and click on a single thing, and I want to deploy this application. We want to move there. We want to move to role-based access control. It's a bit technical, and we want to move to federation and failover, to multi-cloud failover. So whenever AWS is down, and I'm sure everybody has heard of the S3 outage. So we want to just fail over to Google. That should be doable. Yes, for the German rail, containers need to become boring. I don't want the same rate of innovation happening in my platform. I don't want to deal with that anymore. I want it to be stable because I need to depend on it. And I mentioned 5,000 platforms, and Kubernetes now scales to 5,000 nodes. So we have a lot of compute power in what you may call our edge data centers on each track, on each platform. So why not put some kubelets on there and make it part of our platform? This obviously doesn't work because the network is kind of to the edge train stations is a bit not so fast as it is in a data center. And that's it. Thanks. I'm through. Are there any questions?
So thank you. So any questions or comments or observations or yeah.
Okay, thanks. So 2 questions. Are you also running or do you have a separate Kubernetes cluster for production than for example, development and testing, etc.? Or are you just separating with the namespaces?
Yes, we have a separate cluster for production. We also have a separate AWS account for production because that's the right thing to do. AWS has kind of, so it might be a bit specific to AWS, but I would suggest for production workloads, this should always be the case because there's some kind of rate limit you can run into on AWS. So if you query their APIs a lot, they will rate limit you. They will say, at one point they will say, nope, you're not allowed to query my API anymore, you're DDoSing me. So, and they will basically a bit shut down your account this way. So we have a separate cluster running in a productional account, which is the purpose of production.
And then the second one, did I understand correctly that you also run the databases on top of Kubernetes and Docker?
Yes, we are doing that. However, we are doing it only until this far in the CI/CD stage. So for the dev, for the integration, for the performance stuff, and for a couple of different environments, we're running databases as part of the container platform because it's just easy to deploy. It's the same way I deploy everything. But for production and for pre-production and maybe environment before, we're using managed AWS services. At one point, we were doing this decision. We chose to be, so we were at the decisioning point where we had to decide where we database administrators and cluster administrators, or just one of them. And we chose to be just cluster administrators because for the databases, we are running Elasticsearch, we are running Postgres, we are running RethinkDB, we're running a couple of others, and etcd, and you have to have specific knowledge about the distributed, how they work with leader election, how they work in the cloud environment, and how do you recover, how do you do failover, and we chose to do, if we can offload that to a managed service, that's the perfect thing to do. We pay a bit more, maybe, but in the end, we have more time free to focus on the important things.
What are you using for network?
We're using an overlay network. So because every container has its own IP address, a lot of we can stuff a lot of but the scheduler stuffs a lot of applications on a single node, which has as a physical infrastructure with one IP address. So since every container has its own IP address, we're using an overlay network, which is a bit sad because we are more modern than the cloud provider. So AWS uses an overlay network itself, and we are using another overlay network on top of it.
What implementation?
We're using Flannel. That's a pretty major one. And if you don't have a lot of requirements on the network, then Flannel will serve you perfectly. There's also Weave, which is pretty good, and Romana, which is also very good, Calico. But those are even if you're running on a bare metal data center, and you need like this flexibility and connections with other stuff. You need to automatically configure your F5s or something. So then you would look something as Calico, or if you would go with network policies. So if, for example, I mentioned we have this soft isolation via namespaces. But if I want to talk to another environment, I can just use the FQDN of the application, which consists of the namespace is part of the FQDN. I can just talk to that. If I'm running with multiple different, like in a very, very large-scale data center, I don't want to have a customer messing with my environment. So I would need to do some hard isolation on the network level. Then I would go with Calico or some of the more advanced implementations. Another question, or we're out of time anyway, right?
Well, we do have in a way some time for questions or comments if you do have. I think this was quite thought-provoking. If you compare to your own experiences.
So anyway, you can catch me. I'm here a whole day, and if you have some questions, you can just talk to me, and I'll be happy to help. So thanks for coming here.
Thanks.